This little clip introduces the Thyristor. The Thyristor has an alternative name of the SCR, Silicon Controlled Rectifier, and this is basically a description of what we do. We control when we turn the Thyristor on and off, and that's controlled with electronics. Before we look at the Thyristor, I just need to quickly remind you about the diode, because the Thyristor is an enhancement to the diode. Here's a very simple circuit, one diode and a lamp. If we were to consider the supply is DC, here we are, DC supply, and we were to look at what happens, time going that way, and what happens to the current through the load on a DC supply. Here, this diode is in forward bias, current flows through it, and the lamp will light. So the current through the lamp is going to do something like that, nice and steady. If we were to change that supply, so we move from DC to AC, then you need to remember the basics of rectification, and on the first half cycle, current flows this way. On the next half cycle, current could flow that way, but this diode will stop that. So in this scenario, this is the current through the lamp. If we have an AC supply, on the first half cycle, the positive half cycle, we'll have conduction. Then on the next half cycle, no current, then conduction, no current, conduction, etc. So this is rectifying. It's producing only a half wave of current through the lamp. Let's move on now and begin to talk about the Thyristor. The Thyristor is like a diode, but with an extra terminal. We have the anode and the cathode, and this is called the gate. The idea is that this device, the Thyristor, will not conduct, it won't pass current until we pass a small current into the gate to turn it on. So if we had DC, let's take a DC scenario again, and this is the current that's going through our circuit. There will be no current flow. Nothing, zero, until we put a small current for a short amount of time into the gate. So if we were to put a little pulse into the gate, just a tiny current for a short time, then this will turn on. So turn on, and then the current will flow because this was DC. If we were to stop this current for whatever reason, the Thyristor would turn off and we'd need another pulse to turn it on. Let's just take that a little further forward right now. So let's assume we've gone to an AC supply. So we have AC in the circuit, no current will flow, so nothing, until such time as we put a pulse into there. And let's suppose we use this same pulse, we'll have nothing flowing, and when that pulse arrives, the Thyristor will turn on. At this point here, there is no current going through the Thyristor, so it turns off. If it turns off, we'll have nothing, and we need another pulse later on in time to make the Thyristor turn on. Sounds complicated, but it isn't. What we connect just here is a control circuit or a firing circuit, and it isn't complicated. It's made with a resistor, a capacitor, and a couple of other components, and it is designed to produce these pulses. And it works from the supply that is coming in here, the AC, and every time the AC rises up there, the electronics detect the rising, it charges a capacitor, and at some point the circuit will spit out a little pulse. So it's dependent on what the incoming supply is doing. Okay, so just a little more chat about this control circuit. It's dependent on the incoming supply. Not very well drawn, but it'll do. And every time there is a rising edge, it detects that, and we can arrange the circuit to send a pulse, and it will do it every time there is a rising edge. And we get a little pulse, and that pulse goes to the thyristor and turns it on. We can move this pulse along. Oh, sorry, let me just rewind a fraction. The pulses are evenly spaced. They're at the same frequency as the supply. And it's very easy to use electronics to just move them along a little bit in time by creating more of a delay with a resistor and a capacitor. And that's where you would typically get a potentiometer, a knob, on something like a lamp dimmer. And just a slight increase in the resistance, and we move this a little bit further along for every single sine wave that follows, every single half cycle. So the trigger circuit produces a string of pulses that go to the thyristor to turn it on. Let's take another look at that right now. So here we have, on the previous circuit that we had with one thyristor and a lamp, here is our AC supply, and we're going to twiddle the electronics, turn the little knob to put in a trigger pulse to the gate of the thyristor and make it conduct. So what will happen is, once we tweak the knob, we will send a particular pulse, and it will occur at the same point every time. So that is enough to turn on the thyristor, just a low voltage, low current pulse that makes the thyristor turn on. And what is going to happen then is the current to the load will do this. Here is our available supply. We haven't turned the thyristor on until that point in time, so no current flows. And then the pulse arrives and the thyristor will conduct, and it will pass the remainder of the half cycle from that point in time. So it'll pass most of the half cycle. At this point, the thyristor has just turned off. With no current going through it, it turns off. With only one thyristor, this negative half cycle will be ignored, and that takes us on to the next half cycle. This pulse will turn it on, so we've got no current to there, and then it turns on again, and we get the next pulse of current that goes through the load. And so it will go on, doing something like that. Okay. So let's consider this very same circuit, and we're going to change the point in time at which the trigger pulse arrives. So let's consider this as, say, a very crude lamp dimmer. At the moment, the lamp would be about half brightness. But if we increase the delay, our pulses will arrive a little bit later in time. So like so, and it's now this point that turns it on. So the current will be nothing. There the thyristor turns on and only passes a little bit of current through the lamp. So it will be much dimmer, and it will do that all the way along. It will ignore that pulse because it's not working. The negative half cycle is doing nothing, and we've passed that much current. And then then it goes again. So we're just passing that much current through now. So it's very little current going through a lamp, and it will be dimmer. So let's improve that circuit now. This is the circuit we've just been looking at. And with a very simple modification or an addition, we can use both halves of the supply, which is what happens in the real world. So if I pick up this, here is one thyristor, and this is working in forward bias on this half cycle. What we need is another thyristor that will work in forward bias on the next half cycle. So we're going to do something like this. Here is the next thyristor. And we're going to use this same firing circuit to turn this on and off. But what's going to happen now is this will work with the positive half cycle, and this will work with the negative half cycle. Positive, negative. And that will have an effect like this. So here we go again. Here is the AC supply, the available AC supply. Let's trigger it early in the cycle. So if we send our trigger pulse there, then that same trigger pulse will appear at the same point in time on each half cycle. And if we then come down, then the current that is delivered to our load will now look like this. At this point, the thyristor turns off. The next trigger pulse comes in, and the opposite thyristor now conducts. Turn off, and then the next thyristor, the first one, is back in the circuit. Hopefully that makes sense, but you can see how much current is delivered to the load. If we talk about our lamp, and this is a dimmer, we're not quite delivering all of the available full cycle to the lamp, so it would be slightly dimmer than full brightness. If we take this one little bit further, let's move our firing pulse further along in time. So you've just adjusted the potentiometer, the little resistor, the control knob on a lamp dimmer. We've moved the pulse much further along, and that's going to trigger there, 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 there. So the output current delivered to our load now is going to do this. Just a little spike, another spike. So, if we look at the amount of current we're now delivering to the load, to our lamp, there is a lot less of it, and the lamp will be much dimmer. So the example I've discussed throughout this short clip has been a lamp dimmer, but this strategy is very similar to that used in motor speed control, and we will touch on that later on.